Now, Johnny, another way of doing this problem, a method you probably use in 301, you found the profit maximizing output by doing what?
First derivative of total revenue is equal to the first derivative of total cost.
Right. In other words, in economic terminology, you are equating what? Right. You set marginal revenue equal to marginal cost. And let's show that you get the same answer doing that, using that approach. The other approach, the less formal approach, is to set marginal revenue equal to marginal cost and solve for Q. Okay. You recall in this problem, our inverse demand curve is P equals 100 minus Q. Revenue, we found, was 100Q minus Q squared. Therefore, marginal revenue is what? Johnny, what will marginal revenue actually be in this case? Right. Marginal revenue, which is just R prime of Q, is 100 minus 2Q. Okay. And actually, notice that's consistent with what I told you for linear demand curves. The marginal revenue curve has the same vertical intercept as the inverse demand curve, but it's twice as steep. So it's 100, 100 here, and this was minus 1, so it's minus 2 here. So marginal revenue is 100 minus 2Q. Recall that our cost function for this problem was, or is, 500 plus 10Q. So marginal cost in this problem is 10. Just a derivative of the cost function with respect to output, C prime of Q. So marginal cost is just equal to C prime of Q, which in this case is just 10. So set marginal revenue equal to marginal cost, and you solve for Q. Subtract 10 from both sides, you get 90. Add 2Q to both sides equals 2Q. Divide by 2. You get the critical value of Q is 45. Okay. So you could have gotten the same answer that way. There's only one drawback of this marginal revenue equals marginal cost approach, and that is it doesn't necessarily guarantee a maximum. In order to figure out whether you have a maximum or minimum, you really need to check the second order conditions. Okay. Setting marginal revenue equal to marginal cost is equivalent to satisfying the first order conditions for a maximum. Okay. And let's just look at this graphically. I'm sure you're used to looking at this, doing these problems this way. Let's graph marginal revenue and marginal cost. Marginal revenue, 100 minus 2Q, so it's a simple linear function, vertical intercept of 100, slope of minus 2. So the marginal revenue curve looks like this. The marginal revenue curve would cross the horizontal axis at 50. By the way, Helen, if we wanted the output that maximized revenue, that would be Q equals 50, where marginal revenue is just 0. Okay. So our marginal cost curve, horizontal line at 10. So our marginal cost curve looks like this. And then you find out where marginal revenue intersects marginal cost, right here. And that will be Q equals 45. That's where marginal revenue equals marginal cost. Now, intuitively, you can see that the profit is going to be maximized at 45. Because if you produce less than 45 units of output, what is true about the relationship between marginal revenue and marginal cost. At Q less than 45, marginal revenue is above marginal cost. If marginal revenue, say we take this output of 20. If Q equals 20, marginal revenue is way up here. Marginal cost is down here. So what would be wrong with producing 20 units of output? Exactly. You're leaving extra profit on the table because marginal revenue is above marginal cost at Q equals 20. So that means if you produce a little bit more, you would add more to revenue than you did to costs. And then profit would go up. Okay. And that's true for any output less than 45. For any output less than 45, marginal revenue exceeds marginal cost. For any output above 45, marginal revenue is below marginal cost. So then you've gone too far. You produced too much. And your profit would actually increase if you cut back. So intuitively, you can see from this diagram that profit is going to be maximized right here. Actually, there's one more thing we can do in this diagram. We can also show the demand curve, or the inverse demand curve, which looks like this. Here's our demand curve. It's going to cross the horizontal axis at 100. So if you go up from Q equals 45 till you hit the demand curve, that's the price you'll charge. And if Q equals 45, that means you charge a price of 55. So here's our profit maximizing price. So to sum up, the monopolist will maximize its profit by charging a price of $55 per unit. Then consumers will want to buy 45 units at that price. And that'll be the output where marginal revenue equals marginal cost, where profit is a maximum. And we already found out what that maximum profit was. It's $15.25. Okay.